Good morning, everybody. Here's an introduction to oxidation reduction reactions. You can see that we're going to define an oxidation reduction reaction, which are also called redox reactions, as a reaction in which the oxidation numbers for two elements change when you compare them from the left to the right side of the equation. So in order to better understand that definition, we're going to need to know what oxidation numbers are. So in the chart, you can see a list of rules that we apply in this order to assign oxidation numbers. So the first rule is, if it's a monatomic ion, the oxidation number is going to be equal to the charge of the ion. So as an example, if you have the ferrous ion, that would be iron with a +2 charge, its oxidation number would be +2. And if you were talking instead about the chloride ion, its oxidation number would be -1. So again, for monatomic ions, the oxidation number is just equal to whatever the charge is of that ion. The next rule is that if you're talking about compounds, the oxidation numbers have to sum to 0 in a compound. And if you're talking about polyatomic ions, the oxidation numbers are going to sum to the charge on the polyatomic ion. So as an example, if we were talking about the compound iron 2 chloride, the oxidation number of iron would be +2, and the oxidation number of chlorine would be -1, and you can see here that there are 2 of them. And so 2 chlorides with a -1 oxidation number will balance out the +2 on iron so that the whole thing sums to 0. For a polyatomic ion, let's have the example of hydroxide. So if we add up a -2 for oxygen and a +1 for hydrogen, they would sum to -1, which is the charge on the polyatomic hydroxide ion. The next rule is about fluorine, and that is whenever fluorine is in a compound, its oxidation number will be -1 all of the time. So if the compound we're looking at is NaF, fluorine would be -1, and sodium would be +1, so that the sum is 0. And if instead the compound was FCl, fluorine would still be -1, because in a compound it always is, but chlorine now would be +1, so that the sum of the oxidation numbers is 0. The next rule we have is for oxygen. And that rule is that the oxidation number of oxygen in almost every compound is going to be -2. So in something like H2O, the oxygen will have an oxidation number of -2, and hydrogen will be +1, so that 2 hydrogens with a +1 oxidation number will equal 0 when added together with the -2 on the oxygen. Now you can see here that there is an exception, and that's for peroxides. So just as a reminder, peroxide is an ion which has the formula O2, and it has a -2 charge. So you'd be looking for things that have that in there, and then the oxidation number is -1. That's a pretty rare case, but there are peroxides, and so we have to teach you about it. And the last rule is for hydrogen in a compound, and hydrogen is going to be +1 almost all the time. So just thinking about H2O again, hydrogen there was +1, and there's 2 of them to balance out the charge on the oxidation number on oxygen, which would be -2. But there is one exception for hydrogen, and that's when hydrogen appears in a compound as a hydride. And the example that I show there is calcium hydride. So here, calcium would be +2, and hydrogen would be -1. And the 2 of them would give us like a sum of -2 to balance out the calcium's +2. So now let's practice assigning oxidation numbers to the elements in these compounds. I'll start you with the first one and then give you some time to work on it, and then we'll check your answers. So in the first example, we have a compound, and we know that the oxidation numbers have to sum to 0. We have a rule about oxygen, and that is that oxygen is almost always -2 when it's in a compound. So oxygen is going to be -2. Okay, so if oxygen is -2 and there's 5 of them, that gives us a total negative sum of -10. And then there's 2 iodines, and they have to have a positive sum that will be 10 so that the whole thing will equal 0. So since there's 2 iodines, each one is going to have an oxidation number of +5. Okay, pause the video now and see if you can do the rest of these, and then after you're finished, play the rest of the video and see how you did. Okay, compare your answers to mine, and let's see how you did. So we use these oxidation numbers as a record-keeping technique, just so we can see what's happening with elements from the left side to the right side in an equation. We say that oxidation is the loss of electrons. And we say that reduction is the gain of electrons. Now here's a question, of course. Why does the loss of electrons make oxidation number increase? Again, we're using oxidation number to kind of keep track of what's going on with the electrons. So what you will see is that when oxidation occurs, that's electrons are lost, and as a result, the oxidation number is going to increase. So this question is asking, why would that be? Why would the loss of electrons make the oxidation number increase?